In this situation, we are looking at some probabilities. So we've got a fox, and he hunts in these three potential territories, A, B, C, and we're getting just a bunch of information here about if he has a particular hunting behavior today, what is he going to do the next day? And so we're asked to find the probability that he hunts in B on Thursday, given that he hunts in A on Monday. So to get this started, what we want to do is establish the probability distribution matrix, which I'm going to call P. And generally, to set us up, it's going to be a 3x3 because we're going to transition from 3 territories into potentially 3 territories the next day. So usually the way you want to set this up is you have the column headers would be A, B, C, D. That's right, A, B, C. And these would be sort of the actions today. And then they're going to transition into like, what are the probabilities of these things happening tomorrow or the next day? It just kind of doesn't have to be today and tomorrow. It could be Wednesday to Thursday, whatever you like. These are the distributions, and they are fixed. And so we are told that he never hunts in the same territory on consecutive days. So that's going to tell us that like that transition from A to A, which would occur right here. So that entry there is going to be 0. He doesn't ever go from A to A. And then similarly, the 2-2 entry represents B into B, and then C into C would be the other diagonal entry. So he never stays in the same place, and that's what those entries represent. So if he hunts in A, then he hunts in C the next day. So again, we can just kind of follow this transition path here. If he hunts in A, then he goes to C the next day. So that is represented by this entry in the bottom left corner. And so that's 100%. If he hunts an A, then he 100% goes to C the next day. So we're going to put a 1 there. And because we know that the sum of each column has to add up to 1, I can tell that that other entry is going to be a 0 because there's a 0% chance that he goes to B because he goes to C. And so now what we'll do is look at the other information given here. So if he hunts in B or C, so it kind of means that the same thing happens to them. It's twice as likely he's going to hunt in A the next day. So you might just kind of be able to figure out what this number is, but let's just say that I let P be the probability of basically B transitioning into A. And maybe I'll call Q the probability that B transitions into C, because we know that B does not transition into B. That doesn't happen. He never hunts in the same territory twice in a row. So what we're given from this piece of information is that P is 2 times Q, right? So what we're told here is P equals 2Q. So what our column would look like then is, so B going into A is that top entry. That's going to be P, 0, and then we could write Q. And then if I like, I could rewrite that as 2Q, 0, and Q. Now we know that this thing sums to 1. So that does tell us that 3Q equals 1. And so that Q equals a third. So that's how we could figure out how that distribution is. Some of you may have had sort of a natural sort of feel for the fact that that distribution does have to be 1/3 and 2/3. And then similarly, the C1 is going to be basically the same. So 2/3 and 1/3. 1/3. And so yeah, this is our probability distribution matrix. It tells us how we go from one event to the next or one day to the next in this scenario. So we're asked if he hunts in A on Monday. So X0 is going to represent where he hunts Monday. And it's told that he hunts in A on Monday. So I am going to just make a 100 for that. There's a 100% chance he hunts in A because he hunts in A. And so what we want to do is get the probability he hunts in B on Thursday. So that's 3 days later. So we are tasked with finding X3. And so we can basically just do that by finding X1, X2, X3. So I wanted that to be an exclamation mark. So yeah, so I think usually I'd like to just go ahead and find X1 first. So X1 is going to be P times X0, right? We transition from the 0 day, the base day, to the second day, the first day in this case. If Monday is 0, Tuesday is 1. And so yeah, we'd do the whole matrix multiplication. Times 1, 0, 0. And so we get for that, that should be, yeah, we kind of already knew this. I could have done this without the calculation. I should get 0, 0, 1. We know this because it literally says in the question, if he hunts in A, then he does C the next day. So this vector here represents 100% probability of hunting in C. So x2 is going to be P times x1. And it's going to be, again, this matrix times the 0, 0, 1. And in this case, I should get 2/3 and then 1/3 and 0. And then finally, my x3 is going to be P times x2. And again, it's going to be this matrix times the 2/3, 1/3, and 0. I actually don't need the whole matrix. I'm really only interested in the B entry. And so I can kind of go through and work that out. So it is going to be the second row of the matrix times this. And it looks like it is 0. So yeah, that definitely looks like a 0. And that should be our answer. Sorry, I was a little bit shocked by that. I wasn't expecting it to be 0. So you could go ahead and find the probability he hunts in the other two regions. It does work out to be 2/9 in A and 7/9 in C. But yeah, this basically says he does not hunt in B on Thursday. And that's our answer.